Okay, this video is to guide you through the investigation for dispersion. First thing you're going to do is you're going to go to the link that's in your Google Classroom or your email and use the number assigned to you to go to a specific data set. And here I'll show you what it looks like. This is the Google Sheet that the link takes you to. And first thing is you're going to be given a data set. We're going to be learning here about what dispersion means and how you measure it. And one of the things we're going to do that is to create our own data distribution to see how dispersed it is. Dispersion basically means how spread out your data is. Okay? So if you look at the example on top, it's already done. I've made a type of histogram using blocks for the data distribution in yellow. Do you see how, like, for example, I have two 12s and three 13s, so I put 2 blocks above 12, I put 3 yellow blocks above 13. I'm going to pretend that I'm a student here. Let's say that I'm still a student, and I am going to do this for this distribution in orange. And so first I'm going to say, okay, you can see my first data point is 13, so I put a block at 13. Next data point is at 14, so I'm going to put a block at 14, so I'm going to do a Control-C, Control-V at 14. My next data point is 15, so I'll put another block at 15. Then I have 2 data points at 16, so I'm going to put 2 16s. Then I have 2 17s. Okay. So you can just keep going on like this, and you can do it one of 2 ways. One is you can copy and paste the block, which kind of has this annoying tendency of putting this line here, which is not a big deal. Or, let's see, I'm going to put one at 19. I could use the menu up here to change the color. So, like, there is a option here to do the fill color. Like I can do orange. Okay, and then so I could do it that way. I prefer just to do copy and paste, it's faster. I just did 19, and then I'm going to continue with all the other data, and then afterwards I'll come back and show you how it turned out. Okay, so now you can see I've made my histogram, and it looks kind of like this, okay? And then the next step here is it says, okay, in the space you reserved, make a frequency histogram. We did that. What are the possible ways to compare the dispersion of one data distribution to another? Think of at least 2 possible ways. Each method should yield a numeric measure of distribution, okay? And so, like, if I look at this, I look at my yellow distribution and the orange distribution to compare the two. How could I say which one is more spread out than the other? Like, for example, to me, when I look at the yellow distribution, it looks more spread out than the orange distribution. And you might say one of the reasons for that is because the yellow distribution has a wider data set, right? If you take the leftmost data and the rightmost data, it is spread apart more than the orange one. And so like that, you might say, oh, how am I going to do that? I'm going to count the blocks from left to right that it occupies or something like that. So you could 1, 2, 3, 4, 5, 6, 7, 8, blah, 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 blah. Turns out when you get to here, it's going to be 24. So my measure is 24, and the way I did it was I counted from one end to another. So I'm going to record that here in my worksheet. So it says here, what are possible ways? Method 1, I am going to count all the x-axis values from the first block, occupied block, to the last occupied block. Okay? And so, for example, when I do this, I get for the teacher distribution, I got the value of 24. And now let's do the same thing for the orange distribution, see what I get. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Okay, so for the fill student distribution, I got 20, did I say? Okay. And then it says to figure out another method. So, you know, there's no wrong answer here. Just think of a different way you could calculate the width of the distribution. One of the things that you might notice about the yellow distribution that makes it look more spread out than the orange distribution is this big white gap here, where the orange distribution doesn't have that. It doesn't have such a big one. So what if we count the size of the gap? The gap here, the biggest gap in the yellow distribution is 5 wide. So maybe I'll have the second method, which will be to count the longest gap in the data, and then I'll put for the first distribution, the fill distribution, I count 5 as the largest gap. In the student distribution, I count, let's see, right here I have a gap of 2. So that would be another numerical way of counting to see how spread apart the data is, and that would be also fine. Okay, and actually this table I have down here is to simply write down how my distribution compares with the teacher's distribution. So your distribution, I'm going to put that method 1, it turns out to be 20, right? And with method 2, it turns out to be 2. And then for the teacher distribution, using my method, it was 24 and 5. Okay? So do you see how, in this case, either method of measuring the teacher distribution turned out to be more dispersed? But you can see that, like with the first method, the difference in the two indicators was about 4. In the second method, the difference in the indicator was 3. Although, like, if you look at the proportion, it's much larger. Okay, but either way is a defined way that you define how to measure. Okay? Now we're going to look at number 3. It says find the range of your distribution, which is the largest value minus the smallest value. Write the value in the space range provided in the Google spreadsheet. You might think that what you did here for method 1 is range. But let's test that, okay? So let's find the range of the yellow distribution. That would be the largest value, 35, minus the smallest value, which is 12. That would give you a value of 23, okay? So we're going to write that over here in the range space. We're going to put 23, okay? And then we're going to compare that to, oh, look at that. If you look at what we calculated with our method 1, it was 24. It wasn't 23. And the reason why is because when you count each one of these numbers, instead of subtracting, you end up with one additional number than when you subtract. Okay, so be careful, because the method 1 that we had here is not the same as range. It's slightly different. Okay, so if we use range, we figure out that the range of my distribution up here in yellow is 23, and the range of this distribution orange would be, let's see, the biggest value is 32. We're going to subtract from it 13, and so that's going to give us 19, I think. So the range of this one is 19, whereas using method 1, here I'll show you the original worksheet. So look how in method 1 we actually calculated that the distribution was 20 versus 24. But if you look at this, it is 19 versus 23. Okay? So that's range. Now let's see what the next step is. It says, find your distribution's median, the middle value, and write the number in the space median provided in the Google spreadsheet. Mark the colored data square and the histogram with an M. Okay, so first we're going to find the middle value, and there's a couple ways you can do find the middle value. One of the ways is you start from the left and you start from the right and you start counting in a certain number of blocks until you get to the middle block. In this case, we do know that there are 23 blocks, right? I numbered the data here from up to 23. So there's 23 blocks. So what would be the middle block? Well, the middle block in 23 blocks would be the 12th block. So we could count in 12 blocks. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, so we could say that this is the 12th block. And actually I've counted this already. I hid it. So let's do the text color black. Okay, so there is our median block right there, and there's the 13th block. So let's do the same thing with the orange blocks. We're going to count them in. We'll go 1, 2, 3. We're going to find the middle block. 4, 5, 6, 7. I got to count if there's 2 blocks. I got to count each one, right? 8, 9, 10, 11, 12. And the 12th block is the median block. So I'm going to mark the 12th one median. Okay? So I found the median for yellow and I found the median for orange. The median is not 12 for 12th block. It is the data where the median block is. So it's going to be 20 here and it's going to be 22 here. So I'm going to write those down here. It's going to be 22 here and 20 here. You can see they're pretty close. Okay. Next thing it asks for is IQR. IQR is a different way of measuring how spread apart the data is. It doesn't look at the smallest and largest value like we did before with range. What it does is it looks for a block that's kind of a little bit in here and a little bit in here. And the reason why it doesn't look at the most extreme blocks is maybe you're going to have a weird data set where, and I'm going to draw a sketch one here, where like maybe you have a data set where it's like all the data is like clumped up in the middle, but then you just have like a couple data pieces like way out here. And then if you use range to calculate this, you can see that the range is huge, but actually most of the data is in here. So the way IQR does it is it doesn't look at the highest 25%. It doesn't look at the lowest 25%. What it does is it looks at the middle 50% and does like a range of the middle 50%. It throws away the highest 25%. It throws away the lowest 25%, and then it only considers the middle 50%. Okay? So the way you're going to do that here is you're going to count off the data that is in the lowest 25% and the highest 25%. The way you count that out is there's a formula we can use, which is that we take the total number of blocks, which is 23, we add 1, so it's going to be 24, and then we divide by 6. And then the 6 is how much is going to be in each quarter. So the first 25% is going to be the first 6 blocks. Okay, so I can count out the first 6 blocks, and that should get me to the first quarter. Okay, so if I do that, you can see that I 1, 2, 3, 4, 5, 6. The 6th block is my first quartile. Okay, and then I can do the same thing on to find the last blocks. If I count over 6 blocks from the end, then I also find the upper quarter. Okay, so this is called the first quartile. This is called the third quartile. Once I throw away these blocks at the top and I throw away these blocks at the bottom, then I can figure out the range between these 2 points. I don't figure out the range between the most extreme minimum and maximum. I figure out the range between these 2 points that are, slightly inside the distribution, because this is like most of the data, the 50% of the data is here. I want to see how spread apart the middle 50% is. I'm discarding the extreme data on the left and the right. Okay, so here you can see that the IQR is going to be 30 minus 14, right? So I'm going to put that here. I'm going to put IQR is 30 minus 14, which is equal to 16. Okay, and then finally I'm going to do the same thing down here. And I'm going to eliminate, I'm going to count up to the 6th block, and I'm going to mark it Q1. And then I'm going to count up to the 18th block, which is 24 times 3/4, 18, right? I'm going to count up to that, and that will be my upper quartile. 15, 16, 17, and 18 will be my third quartiles right there. So I'm going to subtract 28 minus 17 for the IQR here. 28 minus 17. 28 minus 17, which is equal to 11. So you can see that in terms of range, the yellow distribution is wider. In terms of IQR, also the yellow distribution is wider. Okay? And then finally, sigma. Sigma is the value of the standard deviation. And standard deviation is another way of measuring how spread out the data is. Now, standard deviation is considered one of the best methods to figure out how spread apart data is, because you can see with range and IQR, you can move some blocks around, and range and IQR aren't going to change, right? Because range and IQR only depend on the minimum, maximum, or on Q1 and Q3. It does not depend on every single block. Well, that's not the case with sigma. With standard deviation, what it does is it figures out where the mean is, and then it like figures out the difference between the mean and every single one of these blocks, and then it does an average of that. Okay, so it's like it does a calculation which involves every single block. So the minute you change one block, if you change one block, it's going to change your standard deviation slightly. Okay, and standard deviation is kind of a complicated thing to calculate. The only time you would maybe ever calculate standard deviation by hand would be on your IA. So here what you're going to do is you're going to use your calculator, and we are going to enter our data into StatEdit. We're going to enter the orange data into StatEdit, and then we're going to figure out what the standard deviation is for this data distribution. Okay, and then so I'm going to enter the data in, and then we'll be back. Okay, I've put the data in the calculator, and how did I put it in? I put it in with the list 1 and list 2. In list 1, I put in each one of the data points. So, for example, 13, 14, 15, 16, 17. You see I skipped 18 because 18 there's no data. And then in the frequency list in list 2, I put either 1 or 2 depending on how many blocks were here. Okay, so here's 1, 1, 1, 2, 2, 2, 2, 1, 1, 2, 2, and I skipped the ones that had no blocks. Okay, then I'm going to use stat calc, one var stats, to figure out, and I'm going to put list 1 and list 2 in the list, data list and frequency list, and I'm going to go down to calculate, and I'm going to see what comes out for the mean. There's x bar is the mean, 22.2. Sigma is 5.83. Okay, so the sigma that I'm going to write in here is going to be 5.83. Okay, then we're going to go back to the worksheet, see what else we need to do. So it says to use the calculator to find the number of values in the distribution. What is the symbol? So we're going to look through here. The symbol to find the number of pieces of data in the distribution is n. So you can see it's 23. We kind of already knew that, right? So we're going to write that down. 23, and the symbol is n. Mean, what is the symbol? Well, we know from the previous unit that the symbol for mean is x bar, and the value is 22.2. Okay? And median, what is the abbreviation? The median abbreviation is just MED. So we'll find it here. MED, there it is, MED. And what is the value? The value is 22. It should be the same as what we calculated by hand. And then it has Q1 and Q3. Now we find the range. So the range, how do we find the range? We're going to take the max x, 32, and we're going to subtract the min x, which is 13. Now, the calculator does not show you what the range is. It's letting you figure that out yourself. So the max value is 32. Okay, so it's max x minus min x. And how do you combine them? With subtraction. And you're going to put 32 minus 13, and that's going to give you 19, right? Okay, and then you're going to find the IQR. So the IQR is going to be Q3, which is right here, it's 28. Should be the same as the value you found, and you subtract 17, and that's going to give you, what does it give you? 11? And finally, standard deviation, we already did that before. It's sigma x, okay? And the value we got was, let's see, we wrote it here. Sigma x, the value is 5.83, okay? 5.83. And then it just asks to fill in this data for your distribution and the distribution you're comparing it to, which is the teacher distribution at the top. So I'm going to write my data from here, and then you're going to do that for your data, and you're going to do that for my yellow distribution at the top. Okay? So for IQR, it's going to be 11. For standard deviation, it's 5.83. For range, it is 19. And then I have my method 1 and method 2 comparisons from above, which I'm going to copy in here, and the mean is 22.2, and the median is 22. So 22.2 and 22. And then I'm going to fill in the method 1 and method 2 dispersion measures here, 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 and here. Okay? And then I'm going to answer question 9. So hold on, I'm going to fill all this out, and then I'll be back. I'm going to show you how I figured out the data for the yellow distribution. I did a little bit different just to show you that there's not just one way to do it. I went to the stat edit. This time, this is my data for orange, right? For the yellow distribution, I only used one column to put in the data. I didn't put just ignore this because this is different data. I just put one column of data, and you see I repeated the numbers. So instead of putting just 112 and putting a frequency of 2, I just put 2 12s. I just listed this whole thing out. This is the first way we learned to use stat edit. So I just put in all the data, 12, 12, 13, 13, 13. I repeated the numbers, okay? Then I did stat calc 1-bar stats, and when I did stat calc 1-bar stats, I would need to put list 3 into list, and then for frequency list, I would blank it out because there is no frequency list, right? Now I'm going to get a bunch of data out here, and I am going to get the 8.23 out for sigma x. You can see that's 8.23, and I'm going to note that down in my worksheet. And the rest of them I'm going to compare. So for example, n equals 23, that's what I had before, right? And then I need to make sure that everything else is right. So for example, I used the maximum and the minimum to figure out the range. So 35 minus 12 is 23, and yeah, the range is 23. And the median is 20, yeah. And finally, the IQR. The way you figure out the IQR is you do the Q3 minus the Q1, so 30 minus 14, that gives you 16. So the IQR is right there. Okay, so the numbers I got from the calculator are the same as the numbers that I calculated manually, and I can write here that the sigma value was 8.23. So now my worksheet is almost complete. I filled in the table here, and then there's just a reflection question here which says, do all the dispersion measures above indicate that the same distribution is more spread out, and is that what you would expect? So if you look at this, let's see, 20 versus 24, so 24 is more spread out. 2 versus 5, 5 is more spread out. 19 versus 23, 11 versus 16, and finally the sigma value also indicates that the teacher distribution was more spread out than the student distribution. Now, for your particular distribution, you might not get the same results. Sometimes, or all the time, your distribution might appear to be more spread out by different measures. And that's the thing. Depending on the measure you use, sometimes it might seem that your distribution is more spread out. Sometimes it might seem the teacher distribution is more spread out. You can tell that depending on what conditions you decided to use to measure dispersion, the answer is going to be on one side or the other. Okay, and that is, you know, so yeah, it's not always going to be the same. Is that what you would expect? Well, if you really think about it, you're going to have, like, I'm going to draw a couple distributions for you, and you're going to think about whether or not the distribution is more spread out or not. So I drew a red distribution. Now I'm going to draw like a brown distribution, and then you're going to say whether you think one is more spread out than the other. Okay? So what about this one? Which one do you think is more spread out? Well, it's like, the thing is, you're like, oh, can I just discard these points that are kind of out here as outliers? In that case, the red distribution seems more spread out. Or you say, no, I need to include every single point. So it's like, really, it depends on your purpose. And most of the time, what we end up using is the sigma value, the standard deviation, because it is something that gives a weight to every single data point. Okay, so I just want to hear you talk about what your intuition tells you, because everyone's going to have a bias, and I want you to tell me, analyze your particular distribution, just like you would in an IA. Thank you.